Hey everybody, so we're going to look at writing equations uh, in today's lesson, and we're going to jump in here and look at an example problem. I'm going to show you guys how I go about doing these. So let's first read the problem. It says Jayla is throwing a birthday party at a local restaurant for her mother. The restaurant charges $15 per person for the party, and there's a flat fee of $65 to rent the room. Jayla has budgeted $600 for the party. Write an equation to represent this scenario. What is the maximum number of people Jayla can invite and stay within her budget? So what we need to do is figure out what's changing, what stays the same, and then we're going to use that information to write the equation. Okay, so if I'm reading this, I see that the piece of information I'm not given is, it tells me it's $15 per person, but I don't know the number of people that are attending. And this is going to be the key to this entire problem, is the unknown, just like in any math problem or algebra problem. Okay, so what I'm going to do is I'm going to set this up and say, okay, if no people come, if one person comes, if two people come, if three people come, and I can keep doing this, but I don't really need to do more than this. Okay. The next thing is I'm going to have a column here for my work, and we'll see why here in a second. I need to do some calculations, but basically I want to figure out how much money does it cost for each person that keeps coming. How does that change the cost? So let's see, if no people come, that's $15 for no person, and that's also, there's the $65 fee. So if I do this, no matter what, I'm going to end up paying, this was multiplication here, so this would be just $65. If no people come, I still got to pay $65 to reserve the room. If one person comes, so that's the $15 times 1 plus the 65, and we'll see that this is $80. Then the next one, two people would be $30, and then plus the $65. So this is $95. And the last one, three people would be $45 at $15 a piece, plus the 65 to reserve. So this is $110. Okay, now why was this information helpful? I could continue and do this, but until I reach the 500 or the 600 she has budgeted, but that's not going to get me the equation. How do I get the equation? The equation, we do it this way, okay? First off, we know that she has $600 for the room. And that has to be greater than or equal to, because she doesn't want to spend more than that. She can spend less, but she can't spend more. And from here, we have to figure out what's going on with the x, okay? And this is going to be the basic format for whenever you write an equation. There's going to be three numbers involved. There's going to be a number here times our x, and then there'll be another, then plus another number here. And what do these two numbers do? Okay, the first number is, this is the change, the constant change. And what do I mean by that? For every time that we're moving this number up, how much is this number changing? The second number is going to be what we're going to call our zero value. We'll actually end up calling this the constant later, or another term is going to be the y-intercept. But for now, this is what we'll call our zero value. So let's do the zero value. The zero value is what is the value of the equation when x is 0. So if we look over here and we say the number of people was x, 0 told me that $65 was going to be spent. So I know this equation is going to have plus $65. The constant, and this is the constant change, okay, if we look at each step of that chart we made, we should notice a pattern. Okay, from here to here, from 0 people to 1 person was a $15 increase. From here to here was also a $15 increase. And there are faster ways of doing this problem. We could have realized that, oh, it's $15 per person, that's a rate of change, times that by X. But if we unsure this, these are the steps we can take here. The constant change happening to X is $15. So this is $15 times X plus the 65. This generates the equation that represents the scenario. So these two pieces of information, if you can find these, you can write the equation. It'll always be in this, won't always, but 99.9% of the time, the equations that we're going to be writing are going to be in this form or fashion. What you need to be careful of is if this 0 value is actually 0 and other things like that. But we'll get into that later. Okay, so this takes care of part A. We just wrote the equation to go along with this scenario. Part B says, what's the maximum number of people that Jayla can invite and stay within her budget? Okay, well, let's start solving this and see what happens. The first thing we would do is get rid of any addition or subtraction. So we'd subtract 65 from both sides. And I would wind up with $15 times X is less than or equal to 600 minus 65 would be 535. Next, I would divide both sides by 15 in order to get rid of the $15. That would leave me with X is less than or equal to, and I'm not going to try to do that in my head, 535 divided by 15, 35.67. So X, which is the number of people, is less than 35.67. So what's the maximum number of people we can invite? Well, this number has 35.65 is greater than or equal to X. We cannot round this because if I did 36, if I had 36 people coming to the party, that'd be 15 times 36 plus 65, and I'd be going over my budget if I were to plug that into my calculator. 15 36 plus 65, that would be $605. I'm now over budget. It can't be 36. It has to be 35, okay? Because 35 is less than, or that makes this number greater than or equal to whatever X is. So the largest number of people we can invite is 35. Okay? We're going to be practicing with this in the live lesson. Be ready to participate, and we hope to see everybody there.